For this example, we want to consider the function f of x is negative 2 times 3 to the minus x plus 1. We want to sketch its graph, figure out the domain and the range, and then look at the horizontal asymptotes and where they are for this function. So to do this, we should think about transforming just the normal function 3 to the x that we know how it behaves. Let's draw that graph and draw some points on it and then see how they move when I make these transformations. So if I have the graph of just 3 to the x, that starts down here and then goes up and takes off exponentially like that. And a couple points we know on this graph are the point here at 0, 1, and the point up here at 1, 3. This is on the graph of 3 to the x. Now, if we were to look at 3 to the minus x, that's going to flip this horizontally or reflect it over the y-axis. So that graph is going to look something like this. It's going to start over here and then come up through this same point and go up exponentially, with now a point here on the graph at minus 1, 3, and the point still at 0, 1 there where it's supposed to be. Now if I multiply this graph by minus 2, that's going to flip it over the x-axis and scale it by a factor of 2. So that graph will come from here, hit here, and take off exponentially again. This point here is now going to be at 0, minus 2, and the point over here will be at minus 1, minus 6, because I have doubled that value. Now I'm going to shift up by 1 by adding 1 to the last bit. So I'm going to have start over here, come in through here, and take out exponentially. This point here is now going to be at 0, minus 1, and the point here will be at minus 1, minus 5. So what's the domain of this function? Well, the domain here is all real numbers, the same as any other exponential function. So minus infinity to infinity. What's the range? Well, for the range, we know we don't get any higher than this value here. Right? This value here, this horizontal asymptote that we'll get to in a second, is the highest we get for this function. So we're getting everything below that point, and because normally the asymptote is 0, we have added 1 to shift it up. That means our asymptote here is at y equals 1, and so our range is everything less than 1, and we mean strictly less than 1 because we never actually hit that asymptote at 1. The range is going to be from minus infinity up to positive 1. And like I mentioned before, the asymptote here is at y equals 1. And that's an asymptote when you're going towards plus infinity. On the positive side of the axis is where the asymptote happens. Y equals 1 on the right side of the graph. There is no asymptote on the left side of the graph because that's where the graph goes off to infinity. So let's say you can take a function like this, sketch out the graph of it, and then figure out what the domain and range are as well as where the asymptotes are for this function, which is the f of x here in pink that we got to at the end of this problem.